is equal to e to the power I theta. We can actually write it as cos of theta plus I sine theta. So I'm just representing it in terms of the trigonometric functions, and I'm writing that I theta. Okay, so these replacements we are going to do, and similarly, if I just write down 1 by z, 1 by e to the power I theta, it can be written as e to the power minus I theta. So this would be cos of theta minus I sine theta. So the three problems that we are going to do today, or I am going to give you as task. This is the baseline, okay? This is the underlying idea, and this is something which you are going to use. So we'll add them up. So I can write it as z plus 1 plus z is equal to cos theta, to cos of theta, right? In a similar way, we can also find out sine theta if we just subtract them, right? So that means if I want to write down cos theta, any trigonometric function, let's say, we can actually write it down as half of z plus z. This result, and similar for sine theta, you can just subtract one from the other, and then to do your calculation, this should be 1 divided by 2i. It will be z minus of this. So these results you have to remember. In exam, if you don't remember, you can do it and just show it. Okay, that's also fine, not a problem. And there might be and there might be dz. Okay, if you want to integrate it with respect to dz, it will be dz. So that also we have to find out. So we'll just do it here only, so that you can know z is equal to e to the power I theta. So that means dz is equal to I e to the power I theta. Theta. Just do it, get it. But then if you want to work it from one system to another, you do it in this way. Theta is equal to, you might get a term in terms of theta and you want to write it down in terms of z. That's the aim. Okay, so this would be z divided by e to the 1 divided by I z, because e to the power I theta is z, so I'll just replace it with this. Okay, so this is something which you should know before we actually start today's problems. Okay, we're just going to take up the examples now. Okay, so let me take the first example. Okay, and the technique that we are going to use in the first example, we're going to use a similar one. Okay, so the question is this. Show that many a times you'll get these kind of questions. Okay, so already you know what you have to find out. You have to just do it, integrate it properly. D theta divided by a plus b cos theta. So many a times when you do it, without Cauchy theorem and all, you thought that since it's not mentioned, maybe I can do it directly. Of course, if it's not mentioned, you can do it. But sometimes you won't get the answer. It will be difficult for you. Okay, it will take a time, and you have to do your integrations, and then it will be complicated. So the chances are that whenever these questions are given in mathematical physics, you are supposed to use the Cauchy residue theorem. So even if you don't mention it, you have to use it. If I don't mention it, you can use it. If it's fine, but then don't do it in such a way so that at the end of the day you are in a soup. Okay, you are not finding out. Then you started waste a lot of time. Okay, so better to follow the procedure that I'm showing you now. So this is written in terms of that, and what I'm going to do is I'm going to use the z. Okay, I'm going to replace it with z, so I can use contour integration here. Okay, so that means that I'll integrate it over C, contour integration. Okay, and then this would be 1 divided by A plus B by 2. Okay, and this would be Z minus 1 by Z, and then this is d theta, right? So d theta is nothing but, we have seen, it is dz divided by z. So before I proceed, let me just tell you here that when you write z equal to e to the power I theta and you write it down as cos theta plus I sin theta, you know that sin theta and cos theta will always vary between -1 and +1. So that means the contour that we are finding is always modulus of z is equal to 1. Now, we are all comfortable with it that when we define the contour, we define the limits of integration within which area, within which contour we are actually integrating it. We actually can, discard some of the residues. So that's very important. Okay, so that's there. Okay, but just give me a moment. Okay, something important. Z plus b. I'll open the brackets. I'll just put z square. So I have written equation in terms of z now. Okay, and then the entire thing is divided by 2z, right? So we can just take up the LCM here. I think just a sec. Yeah, this is okay. So this dz divided by z, and this entire thing is divided by 2z. So I've written a 2z here. I think this is correct. So I'll take 2 here. So this will be 2z. So I can just cancel this z out, right? So this is 2 divided by something. Okay, and I can actually take out this 2 by I here. Okay, there should not be 2 here. Just wait, let me check it once. I hope I did it correctly. Anyway, let me just check it later. 2 by I. You can also see, okay, and check, tell me if something is wrong there. And then if I just write it down in terms of z as a quadratic equation of z, I will bring z square before. So I'll bring z square here. And then plus 2 times of az, 2 times of a z, and in front of z square there is a b, so I'll divide by b throughout, so I'll put a b here. Okay, plus, so that's why I've written z square here, and then this nothing but 1, right? So divide throughout by b. Okay, so you can just do it that way. Okay, so you have it here, and then this is dz. Okay, so that's how we are going to write it down, right? So when you divide by b, obviously you have to multiply by so I will write down this b outside here. Right? So you have got the equation which is quadratic in terms of z, and then what we can actually do. Okay. It's a second order, it's basically a differential equation. So what we can have is this. We have this z square plus 2 times a z divided by b plus 1 as our equation, right? Or this value of the formula that we have. Okay. Someone messaged in our group. Okay, no, that's fine. Okay, so I use the technique to solve quadratic equation. I can find out for z, and it is minus b plus minus root over of b square minus 4ac divided by 2a. So minus of b, so our b, the coefficient is 2a by b. So minus of 2a divided by b. I hope you remember this. Plus minus root over b square. So b square means it's 4a square divided by b square. B square minus 4ac, so 4 times a's coefficient is 1, b is coefficient is 1, okay, so it is 4ac. I'll just put 1 divided by 2 times of a, so it is 2 times coefficient is just 1, right? So if we just simplify this, I can just separate it out. 2 will get cancelled, so I can just write it down as a divided by b, and then plus minus. You can take the 4 out, and then it will be outside the root, so it will be 2 will get cancelled, so this is again a square. Okay, and then this b square, you can take the LCM, so it is a square minus b square, and there will be a b at the bottom. So this is there. Okay, these are the roots that we have. Okay, and we can really write it down as something like this. Okay, I'm just trying to make it simplified. You already know about the technique. This is minus of a divided by b plus root over of a square minus b square divided by b, and this beta is equal to minus of a by b minus root over of a square minus b divided by b. Okay, we're just going to do it in detail. I think that's very important. And if you look here, and if you look into the values and all, okay, it's just a minus a divided by b minus of root over of a square minus b square divided by b. So whatever value you are going to basically put up here, this beta value is always going to be less than minus 1, right? If you look into it, okay. How we are going to use this particular idea, we're going to see that now because you already know about the residue theorem, we're going to use it there. Okay, so let's just get back to our equation now. So our expression was this, okay, our expression, the integral, just write it down as I for short. This was actually 1 divided by bi integration c 1 divided by this part, right? And this actually we have already found out two roots, one is alpha and one is beta. Means I can write it in terms of the root, so I can write it down as z minus alpha. You can always cross check, but then it is something which you already know. It's mechanical. Z minus alpha and z minus beta. Okay, and I will just put it as dz. And then if I just want to integrate this, this is actually having poles alpha and beta. I already found out what is alpha and beta. And in that way, what we can do is we can just simply write it down as 1 divided by bi. And if you remember Cauchy's residue theorem, I can just put it as 2 pi I into whatever is the residue R1 plus R2. Right? Now, this is in terms of z, and the contour is modulus of z is equal to 1. So that means it's going to be between minus 1 and plus 1. If you look into this beta value, it's always going to be less than minus 1 because of framing, see this one, okay? So that means that this R2 will be equal to 0, okay? Since it is outside the contour. See, let me write it down. That's it. Okay. So this is basically going to be 0. You'll see that you have to analyze it in such a way so that you are getting it correctly. Okay, that's very important. So that means I have to just find out the first residue. And if you remember, this is limit z tends to, this is alpha, right? We're talking about alpha and beta as the root. So limit will be z tends to alpha, and then this will be z minus alpha. That's how we do integration. 1 divided by fz. Fz is 1 divided by z minus alpha, z minus beta. That's how we are going to use the residue theorem. So if you attended the last two classes, this is going to be very clear to you. I think you already know it. So this is 1 divided by alpha minus alpha. Alpha minus beta. Right? So alpha minus beta. So we can actually simplify this and look into the value of alpha minus beta here. Okay, so if you just take it pure, I guess might be able to let them look alpha minus beta. So this is alpha minus beta. So the first term gets cancelled, and these two terms are this is alpha. So this will be plus. Okay, so this will be 2 times, right? So I can just simply write it down as 2 times of root over of a square minus b square divided by b. Right? If you do it that way, you get this. And this is 1 divided by alpha minus beta. So I'll just take the reciprocal of this, b divided by 2 times of root over of a square minus b square. So that's my residue, right? So I already have my residue like this. Okay. And that means I can simply find out what is my value, right? So if I do my calculations now, okay, I can just simply write it down as this. This is C F Z T Z is equal to 1 divided by B I. 1 divided by integration, right? So this integration we have already that this would be nothing but 1 by B I is 2 pi I. So this is 2 pi I. And the residue. The residue is B divided by 2 times root over of a square minus b square. Something I missed, it seems. Just wait. Oh, sorry, there was a 2 here, right? There was a 2 here. There was a 2. Yeah, this 2 was there. Sorry. So there is a 2 here. Check it. and there is a 2 here, right? So this 2 and this 2 you can cancel out, okay? This and I will get cancelled out with this, okay? And you are left out with 2 pi divided by root over of a square minus b square. So if you just go here, what we are going to show is this 2 pi divided by root over of a square minus b square, and this is what we have shown. So I'll give you some time to actually understand this. This is actually very simple, but then you have to use here and you will get these kind of sums. So as you look in sum, you should be able to identify what to use this statement concept. Okay, so most of the times in analytical physics in this particular unit, if you're getting kind of questions, the chances are that you're going to use this technique. So you have got theta written in terms of theta, you have to write it in terms of z. So once you write it down in terms of z, you actually will, everything will follow mechanically. You have to just replace it correctly, and at the end you should get actually a quadratic equation. And once you get that quadratic equation, you are going to solve it this way, going to find out the roots, and then you can write down the roots here. Okay, so once you've written the roots, you can just talk about the residue. But when you do the residue, you have to check whether this is actually in accordance with the question or not. So whenever you are given no other condition, only you are given this contour integration, only this integration, you're converting into a contour integration, you're writing it down in terms of z. So the only condition that you have to look into is that z lies between -1 and +1. On the other hand, sometimes there will be some kind of restriction in values of a. Suppose a is a variable here or b is a variable here. There will be some kind of restrictions, and then also you have to check whether to see whether it fits into the Cauchy's residue theorem or not. First thing. Second thing, in your exam, if you just want to twist the question, what I can do is maybe I can give you some value of a and some value of b, and you might be a bit confused because I have not given a. These values are given already, a and b here. If I just replace a by 3 and b by say 2, this will be 9 minus 2, right? So it will be root 7. So the answer will be 2 pi by root 7. Okay. So if I give this, don't get confused. It's the same technique that you are going to follow. Okay. So that's something which you should. That's very important. Okay. But you not with a and b, you just use it with whatever values that are being provided. So let's take one more sum, because these kind of problems, the more you practice, the better you can. It takes time to get hold of this. Okay. If you get one or two clearly, then I think the rest of the things should not be very difficult. So the next problem is 0 to 2 pi. Most of the times you will see that this is the integration limit that are given, d theta divided by 1 minus, 1 plus a square minus 2a cos theta. And your a value will actually lie between 0 and 1. So important. Okay. Sorry. Okay, so try doing this. Important. I just don't want to leave this halfway. I want to actually make sure that all of you know to do it. Okay, that's very important. So this is the one. Okay, and then if we just write it down as 1. Yeah.
So that is my answer is 2 pi upon 1 minus a square, not 2 pi.
Yes, sir, that's the answer. 2 pi upon
2 pi upon
pi upon
1 minus
1 minus a square.
I'm not saying
yes.
at that time I
Okay.
did not see the is said same answer.
Okay. No problem. So let's just see. Okay, let's keep checking. Others keep doing. If you have the answer, you can just interrupt me and tell me. Okay, let's karte hain. So although I've done it on a page, but I'm practicing it again. So it also gives me a confidence of doing it again and again. More you practice, even the same sum, it still feels good. So 1 plus a square into z. I will just separate the z's here, right? So plus, and then this you can write it down as a. So this 2 will get cancelled. And what we have here is a z there. So just the LCM, this can be written as z square plus 1. Right? And then of course, you have a z here. You take the LCM here, you get one more z, z cancel. So I don't need really do also. And I need to get rid of a in front of z square. So that let's write it as 1 divided by AI. Okay, okay, and okay, then I just out on a sign here. Where is it now? Yeah, a second. This is minus, and is the minus also I need so just outside so that I have got a quadratic equation z. So this from here, and then after this out, so I'll put up my and the term is 1 square, and this it was say with e, so just divide it by so the a get cancel like thing. Okay,
Hello, sir.
and this
Hello?
yeah.
Sir, I got second one. 2 pi by 1 minus a square.
Yeah, correct answer. So if I just do it, okay, you can do it in different ways, but then you cannot just do this equation, right? So this is z square minus 1 plus e square divided by a into z plus 1 by square into z. So if you solve this, you will b plus plus is going to a, okay. You should get something like this. Please do it on your own, which is I'm not going to do it. Divided by a plus minus 1 minus a square divided by a. This is something which I got. And you can take alpha. So alpha, let's say I'll just use plus here. Take LCM here. This will be 2a. On top it will be 1 plus 1 minus a square get cancelled. So 2 gets cancelled. It is 1 by a. Right? So if you just do it, it will be 1 by a. In a similar way, if you do beta, this is minus, so this will be minus, this will be 2 on top. Okay, this 2 will get cancelled. Okay, this is a. So check it out. Okay, so these are the roots of this. So it means what I can do is simply write it down as 1 divided by ai integration c t. Please put the c. That's again important, and this is z minus alpha. So z minus a and z minus beta, so that means z minus. Very simple. Okay, and what we can do now here is this. So separate this out. Okay, let's not get confused here. I have to find out the residues now. Okay, and if if I want to find the answer to this is nothing but minus divided by ai into there are two, so it is 2 residues, that is 1 plus r2. Okay, so first let's find out r. So r1 is limit is a, and this will be z minus a. This is r. I'm relating this with r1 because r2 will become 0. Tell you why. R2. Okay. So z minus a 1 divided by z minus 1 by a into yeah.
So the second answer was the correct because actually I didn't see the A part was extra term there.
Okay. This term should not be there, right? Okay. Anyway, so this is there. This will cancel. This is z minus a. So this would be 1 divided by a minus 1 by a, right? So this would think about if you just take out the LCM, this is a square. So a square minus 1. Right? Okay. Actually, I write it directly. So if I write it directly, the numerator this will be a, and the denominator this will be s minus 1. Okay. R2 is 0 because a will lie between 1, and let's imagine. Okay, let me make some space. I don't want to shift to the next page, otherwise it's confusing. So let's, a is between 0 and 1. It's a condition which is given, and let's say I'll just take this value. A is equal to 0.5. Chalo, let's say. Okay. So we have got z minus 1 by right is equal to 0. So that means z is equal to 1 divided by 0.5. That means z is equal to 2. But z should be 1 because if as soon as you convert it into this contour integration, z will lie between 1 plus 1 and minus 1. That is 2. If you put in the limit of a, that means part 1 is plus 6. So if we what I want to do is 2 pi divided by a into 1 is a divided by is 1. And so there's a minus, I think this is just 6. So this is obviously 2 pi divided by minus a square. Okay. So that's what many of you got. So obviously that's the answer. Okay. So now my job is not to see that only 7 or 8 of you have done and then others, I'm not sure. Because sometimes but then it doesn't mean that you didn't practice. You have to practice because if against these questions, actually it will be an entirely different problem. Okay. And I don't have to change much. Okay. I have to just replace this cos theta with sin theta. So if you replace this cos theta with sin theta, sin theta, you're going to get an entirely different question. You need to get an entirely different root here. Okay. So you have to be very careful that what is asked, and then you have to just follow the mechanical steps. Okay. And that I think is the beauty of doing mathematical problems. If you don't understand it, usually you don't come up with the correct answer. That's very okay. Let's do one more. Okay, so many. Let's do one more. This will be, this topic is actually under application of Cauchy's residual theorem. We are using a complicated sum. We are converting it into the imaginary part and the real part, the z component. Okay, and then we are doing the simplification. So that way this sum becomes simpler. Doesn't mean that we cannot do it in else ways of solving this problem. 5 minus 3 sin theta minus, and to show that this is equal to this is some question which is already number. This should be 5 pi divided by 32. Okay, try this. Okay. And I think I made a mistake. I should not have told answer. Okay, you might have found out, and then I'd have told you that this. But anyway, just do it. Okay? You get that confidence that you're doing it correctly. Very important. So 1 divided by, and this is 5 remains as it is. Minus 3 is the same. And when you take it sin theta, this will be 1 divided by 2i. So it is 3 divided by 2i, and this is z minus 1 by z. This is we've seen. And then square, and d theta is dz divided by z. So you have to take LCM and everything else, and then you have to more or less simplify this. So when you simplify this, okay, you take the LCM and everything, you take that 1 by I outside and so on, you should get this minus 4 divided by I. So I'm not doing it, okay, we've done it a number of times. This is z dz. Just check it once, okay? I may be wrong also. Sometimes I make wrong steps, but I hope it's okay. Z dz divided by 10 I z minus 3. This is z square minus 1 whole square. So when you simplify this, you should get something like this. Might keep 4 inside outside. You can just check, okay? And you have to just convert it into z square. We just in a quadratic form. So this will be minus 4 divided by, now here it is z square inside. For this square will always be there. Okay, you don't do anything with it. Just put square bracket and put that there. Just simply what is inside bracket. So this is z square, and this is 3. And if I have this square, I do consider this square now, and then I have to take this 3 entirely out of it. This will be 3 square 9. So that means I have to divide it by 3 and multiply it by 3. So that means I'll just take this 9 outside because it's 3 and then there is a square, so it is 9i. So I'll just take this out, and then I think we are almost done. The set, put C here. and divided by, and open this bracket, and it's a
Sir, I
square
got the
term,
answer.
so you got the answer. Okay, that's good. So it's a square term, so I can take minus and plus, interchange it. So it is z square minus, this is 10 I z divided by 3 z minus 1. Okay. Okay, I think I got momentarily disconnected. Okay, I'm back. Okay. So this is the quadratic form that we got. And then, you can use your equations, differential equation, quadratic equation, you can solve it. And then the roots that you should get is, solve this, the root minus b plus minus root over b square minus 4ac divided by 2. Use it, you'll get z, one root should be 3i, and the other root would be I by 3.
I by
Okay.
3.
Yeah. Okay, that's good. Sorry, not I. Alpha and beta, right? Alpha and beta, or beta and alpha, whatever. So check this, and this is 3i. Code to this, z is equal to 1, that is minus 1 and plus 1. So 3 is there. It will be obviously having a residue, right? So then means you can just do it. And to just do it here, it will be minus of 4 divided by 9i. This is there. And then integration of fz dz. So this is nothing but, this, maybe I can just write it down here. So that means this particular term, I'm just doing it fast, okay, it's very simple. Z minus 3i, I'll write it 1, and the other one will be z minus I by 3. So I've got these two, and okay, and then of course it's squared. So it's squared here, okay. So now I have to find out fz. That means I have to write down it as minus of 4 divided by 9i, and then this is 2 pi I into R1 plus R2. So this R2 can be considered 0, okay, since modulus of z is equal to 1, right? Modulus of z equal to 1, right? So this is 1, so I can just ignore this alpha, I can take it for 1. So if I just do it, okay, if I just do it, I can just write down what is my R1. R1 is limit z tends to I by 3, and this is first, it's a pole of order 2. You have to check it, very important. This is a square term, so that means this will be 0, but this will be z minus I by 3, but it is squared, so it is a pole of order 2, so that means I have to differentiate it. Okay, so the done it before, you have to remember this. This is 1 divided by factorial n minus 1, n is 2, and then d n minus 1, that means d1 dn minus 1, so that means d dz of z minus I by 3 order 2, so square divided by z into divided by z minus I by 3 square and z minus 3i square, right? Because both these terms are squared, so I can separately also square them out. Cancel this out, okay, and put the limits. Everything when done, you should actually get to be, okay, 90 divided by 8 into 8 into 8. Okay, just put values here, I by 3, okay, simplify it, okay, and then you should be actually getting some answer. This is a square term, so let's put the values, okay. So once you get this, you should get your fz. I'm just giving you the intermediate steps. I've not solved it in detail. I expect that all of you are actually going to solve it in detail, okay, that's very important. So this is minus of 4 divided by 9i into 2 pi I into 90 divided by 8 into 8 into 8. So if you're getting these intermediate steps correct, you should get the answer, right? So this gets cancelled, this gets cancelled, this is 10 I चला गया, and यहाँ से this is 4, this 1, this 2, this is there, this is there, this is 5. So this is 5 pi,
5 pi by 32.
yeah, 2 and 2, this is 4 into 8, 32.